This playlist deals with some aspects of Eurocode 2 version 2023. Watch this channel for further selected topics. This video is about clause 11, detailing of reinforcement, part 4, and it deals with anchorage. We've seen in the previous video the formula for the anchorage of straight bars, and I've written this formula again here on the first on the slide. Comparing this with the formula for anchorage length on version 2004, then we arrive at this formula. Looking at those two equations, it is obvious that the new formula is easier in application than the existing formula. You also see that the ratio anchorage length divided by the bar size, that it is independent or almost independent of the diameter for the version 2004, but it is dependent on the diameter in the version 2023. So that's a big difference. We will now investigate this formula for concrete quality 20, 30, and 50 megapascal, for steel stress between 0 and 609 megapascal, which is 700 divided by 1.15. And for a diameter 12, 14, 60, 20, 25, and 32. For a diameter smaller than 12, it is the same as for diameter 12, but for the version of Eurocode 2 2004, there is a small difference, but I did not take this into account. And I have a fixed concrete cover CD equals to 50 millimeters. We will make an investigation for RIT bars only in good bond intention in the ultimate limit state persistent, and there is no confinement or transfer reinforcement. It's just plain anchorage of straight bars. We can now make a graph of on the y-axis, it's the ratio LBD over phi. On the x-axis, it's the steel stress, tensile steel stress. And the dotted line is the 435 megapascal. And we've done that for different diameters. The diameter goes up from bottom to top. So this one is for diameter 32, then 25, that's 20, and so on. And the last one is for a diameter 12 or smaller. That's for the Eurocode 2 version 2023. The first thing that we notice is that, of course, you have a minimum anchorage length that you will see here. That's the minimum anchorage length. And we also see that the larger the diameter, the more anchorage length you need, which is logic. You will see that this line is not linear. It's bent. That's because this anchorage length, LB over D, the ratio, is a function of phi. So that's why this is a little bit bent. In version 2004 of the Eurocode 2, it is a straight line. So you must be careful if your steel stress now doubles. In the present Eurocode, it doubles also the anchorage length, but in the Eurocode version 2023, it does not necessarily do so. It can be different because this is not now a straight line. Taking the dotted line of 435 megapascal, which is 500 divided by 1.15, and you will see when we take now all those different cross sections or crossings here, and we look at the values, for instance, for diameter 32, you end up here with something more than 50, which is 52.3. So This table gives you an idea. In the example that we got here with CD 50 and FCK 30 megapascal, concrete quality of 30 megapascal, we see that you need more than 50 times the bar diameter for just a straight bar, to anchor a straight bar, if you do not take into account confinement reinforcement and transfer reinforcement. The minimum in this example is more or less 25 times the diameter. And for bar diameter 16, it's 30 times the diameter. For concrete quality of 30 megapascal, and we take now, for instance, the diameter 20 millimeters, we have the same graph, x-axis the steel stress, y-axis the ratio, and then the full line is Eurocode 2 version 2023, and the dotted line is Eurocode 2 version 2004. So you will see that this is a straight line, this is not a straight line. But what is interesting is that almost everywhere, the anchorage length for Eurocode 2 version 2023 is bigger than the one for Eurocode 2 version 2004. But for small steel stresses, you will see it's inverse. So for small steel stresses, the anchorage length according to 2023 is smaller than the one according to 2004. So if you now divide those two, the ratio of the values for 2023 divided by the values 2004, then you will see when it's less than 1, then the anchorage length is less, and when it's bigger than 1, the anchorage length is more. So you see exactly this crossing is equal to this one, and then you have this dip and then horizontal, and in most cases it needs more anchorage length. Here in our example, we are ending up till 50% more anchorage length. So this principle, remember this principle, we'll show more graphs where you will see this principle, and now you know where this is coming from. It's from this graph. When you have a concrete quality of 30 megapascal and CD is 50 millimeters, we take the same type of graph that we've seen in the previous slide. The dotted line is for 500 divided by 1.15 as steel stress. And this is then the ratio 2023 divided by 2004. And this is the increasing bar diameter. You will see that for a bar diameter 32, you have 60% more, and for a bar diameter 12 and less, it's almost equal. For full yielding of the anchorage bar, full yielding meaning 435 megapascal. So take care of this, that you know that you need huge anchorage lengths. First graph now is on the x-axis the steel stress, the y-axis is the anchorage length, or it's the ratio of anchorage length divided by the bar diameter. And this graph is for concrete quality of 20 megapascal, the middle one for 30 megapascal, like we've seen just now, and the right-hand one is the one for 50 megapascal. Just to show you the influence of the concrete quality. You see immediately, if you compare it with 30 megapascal here, then you will see for 435 megapascal steel stress, you arrive almost at 50 times the diameter. When you use concrete quality 20 megapascal, you see immediately it will increase up till 65 or more. So you go up from 50 to 65 times the diameter as anchorage length. On the other hand, when you do not have enough anchorage length, but you can increase the concrete quality, then it will help you a lot, because For instance, for a bar diameter 32 at 435 megapascal, you need 40 times the diameter compared with the more than 50 times the diameter for concrete quality of 30 megapascal. The graphs are made on the same scale, so you can compare it visually, so that you can see that there is a huge impact of concrete quality on the needed anchorage length. Again, for the three concrete qualities, I've put the graphs with the same scale next to each other to give you an idea. We've seen this graph already. This was for diameter 20. The full line was version 2023. The dotted line was version 2004 of Eurocode 2. And you see what will happen for concrete quality lower than C30. You have the same principle. There is a region where you need less anchorage and a region where you need more anchorage length. But when you increase the concrete quality, you will see you always need more anchorage length in the Eurocode version 2023. And then again, for the three concrete qualities investigated, we can put the graphs of the ratio 2023 divided by 2004 of this ratio against the steel stress in the reinforcement bar, then you will see that you have the same type of graphs, and that as from C50 onwards, there is no part where you need less anchorage length, unless you have here the small diameters, which is 12 and 14. Then you have a very small zone where you need less anchorage length, but that's only a small zone. But in general, it's always more anchorage length. And to finalize this video, when do we need the minimum anchorage length of 10 times the diameter? Well, you will need the minimum anchorage length is dominant when the steel stress is smaller than the value given in this table. So I've made this table for 20, 30, and 50 megapascal, and for different diameters of reinforcement bars. And you will see that you only need the minimum anchorage length when the steel stress is not very high. This is handy. You can use this table because when you have a support where the steel stress is almost going from 0 to 200 or something like that, then you can see immediately where do you need only 10 times the diameter as an anchorage length, and it makes it easy instead of calculating the whole formula.